All right, we're back. We are going to do example 2 now for linear programming. So you have another example for 2.7 to look at. I will need with you. So I'm going to share that. And we are going to look at this problem. This is another example. And again, just start the same way. Farmer has 10 acres to plant wheat and rye. He has to plant at least 7 acres. However, he has only $1,200 to spend, and each acre of wheat costs $200 to plant, and each acre of rye costs $100 to plant. Moreover, the farmer has to get the planting done in 12 hours, and it takes an hour to plant an acre of wheat and 2 hours to plant an acre of rye. If the profit is $500 per acre of wheat and $300 per acre of rye, how many acres of each should be planted to maximize profits? Okay, there's the question right there. And this is important in these. If they don't give you kind of the step-by-step, I always look for the question. And let's do that where it doesn't look so much like I have a crayon in my hand. I always look for the question, and it's going to tell me a lot of things. It's going to tell me what my variables are, because this one, if you notice, does not tell me my variables. So it says how many acres of each. What do you think they mean with each? They mean wheat or rye, right? So our variables have to reflect this question, because that's what we're solving for ultimately. Our unknown is how many acres of wheat and how many acres of rye should be planted to maximize profit. So it also tells us we're going to have a profit equation again that we're going to have to write. So I'm going to start out by writing my variables. Again, very important that you write this as a quantity. So it's number of acres. I'll say X is number of acres of wheat, and you can use other variables. If you want to make it a little more descriptive, you can use W and R. I just always end up going back to X and Y just because it works nicely on a graph. And then we'd have number of acres of rye. So these are our two variables. So now I'm going to go back through, and I am going to start to find my information and my limits. A farmer has 10 acres to plant in wheat and rye. What is that? What is this 10 acres? They gave us numbers. We have to figure out what that is. That's a limit. All right, so that's going to be an inequality. We have 10 acres to plant total of wheat and rye. So that limit would be expressed by saying X plus Y is less than or equal to 10. This is very similar to what we had where we had the production capacity of the plant in the previous problem. So we've got one of our inequalities. Now, again, I'm going to look through this and keep going. I'm going to change colors. Use something else. All right, he has to plant at least 7 acres. Well, that's another limit. It's a lower limit on the same thing. So you could write a second inequality here that says X plus Y has to be greater than or equal to 7. Or you could have just added it on this end and said X plus Y greater than or equal to 7 and had it between 7 and 10. Or like I said, either way, do it as a separate one, or you could have combined these into something that looks like this, right? Either one of these two combinations. All right, so again, I'm going to change color again just to get something. All right, so now, however, he has only $1,200 to spend, and each acre of wheat costs $200 to plant, and each acre of rye costs $100 to plant. All right, so we got the cost of wheat to plant per acre. We got the cost of rye to plant per acre, and we've got the total amount he can spend to do this. So this looks like the limit, right? So that being the limit, that's going to be our less than or equal to. Whatever we do has to stay under $1,200. So the cost for wheat is $200 per acre, and the cost for rye is $100 per acre, and we've got another inequality here. Okay, so I'm going to go to the next sentence, change my colors again, and see what we got. Moreover, the farmer has to get the planting done in 12 hours and takes an hour to plant an acre of wheat and 2 hours to plant an acre of rye. All right, 2 hours for rye and an hour for wheat, and there's a limit of 12 hours. That's what I see in that sentence. So I got to write another inequality that's limited by the time he has to get this stuff planted. So I'm going to be less than or equal to that 12 hours. And my acres times an hour would be wheat. So that's just X. However many acres, that's how many hours it's going to take me. 2 hours for each one of rye. So I'm going to say X plus 2Y has to be less than or equal to 12. And I have another inequality for that sentence. Okay, so change colors again. And let's see what we got. If the profit is $500 per acre of wheat and $300 per acre of rye, how many acres of each should be planted to maximize profits? All right, so now we're talking about profit. Profit is 500 per acre for wheat, 300 per acre for rye, and we've got our f of xy. Our f of xy will be equal to 500x plus 300y. And I think I'm done. Now I have to look at this and say, I don't have one other set of inequalities that I think I should have here. And this is the one I mentioned last time. I'm going to make sure that I mention that x and y should be greater than or equal to 0, because I have x plus y being greater than or equal to something and less than or equal to other. But just to be sure, I'm going to put those in there because I do know that I have to be in the first quadrant. So now I got a bunch of stuff to graph. All right, x plus y equal to 0 or greater than or equal to 0. I'm going to do those right away just so we know we're in the first quadrant. And I did those with this color, so I'm going to do that here. All right, so my line is going to go from here down. And I don't have a scale on my graph yet, but I know this is going to be okay. And I know I'm going to have another line here going down that axis. And let's go back here, put arrows on those. All right, so I mentioned the scale. Looking at this, I'm looking at my inequalities and the boundaries that they're going to have. I have numbers as low as 7 and 10. And then here, even though it looks like a big number with 1,200, these are by hundreds. So I'm looking at maybe the biggest number being 12. And it looks, again, maybe 12. So I don't need that big a scale here. I don't need to go by hundreds or anything. I think by ones should be good enough. So if I go through here and just make, that'll be 5, 10, let's see, 11, 12, 13, 14. That's probably good enough. Just do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have that, and I think that would be 15, right? All right, so we've got our scale. Now let's look at graphing the rest of these. Let's go graph the red one. So I need my line, and I need red. And we'll do x plus y less than or equal to 10. So we're going to be graphing, whoop, I don't want my line yet. We're going to be graphing x plus y equals 10. So when x is 0, y is 10. When y is 0, x is 10. So I know I'm going between 10 and 10 over here. And now I need my line. So I'll do this. And I want it to be red. And we'll go from here to here. Okay. So we have that line. And we're going to be underneath that. So we've got kind of a triangle again. And we got rid of x plus y equals 10. So now let's go back up. We got to do x plus y equals 7. So let me get green going. And x plus y equals 7 is going to again be at x equals 0, y equals 7. And y equals 0, x equals 7. Right? These are supposed to be y's. All right, so we have that. So I'm going to go between 7 and 7. And I need a line, and we want that line to be green. So let's do that. We're going to go over here from 7 down to here at 7. And we're going to put our lines on that and that. And we want to be greater than or equal to, right? Remember, that was what we had here. X plus y is greater than or equal to 7. So 0, 0 would not make that true, so we go on the other side of it. So we got this kind of tube going along here now of values that are cut off at the end, right? So now we got a couple more. We got our orange one to do, so let's get there. Let's get orange going. We've got 200x plus 100y equals 1200. So when x equals 0, y equals 12. When y equals 0, x equals 6, because 6 times 200 would give me 1200. So I've got 6, 0. So I'm going to go from here to 0, 12. And I'm sorry, 6, 0 would be here, and 0, 12 would be there, right? And I need to draw a line between them. So let's do that from here down to here. And we have that line. 0, 0 would make that original inequality true, so we want this side of it. So we have cut off another piece of that tube. So we're in this area over here now. That's where all our solutions overlap. And we've got one more to do. We've got our x plus y equal x plus 2y equals 12. And we need to graph that. So x equals 0, y equals 6, y equals 0, x equals 12. So we've got 0, 6, that's here, and then we've got 12, 0, that's out here. So I need to draw a line for that. And we'll go from here to here. And that gives us this. And again, 0, 0 would make that true, so we're going below this. So you got to be careful here. Don't try to, everyone wants to jump to this, but really our solution is that little area in there. It's this little spot down here, this little triangle, guys. So I want you to be careful when you're doing this. Don't try to guess where the area is. Go by what it tells you when you do the inequalities. So we're doing this little area in here that has 3 vertices. It has one here, and one here. Now, my graph is pretty accurate, and I think we may have the solutions, but you should always check. So let's see, if I call this A, this B, and this C, let's see what they look like and see if they work. A appears to be at 2, 5. Well, 2, 5 should make the blue equation true. So the blue equation would be 2 plus 2 times 5 equals 12. That does make that true. It should also make the green one true. The green one is x plus y equals 7. Well, 2 plus 5 does equal 7. So A being 2, 5 looks good. B looks like it is 4, 4. And 4, 4 should make the blue one right. So it'd be 4 plus 8 equals 12. That's true. And it should make the orange one right because this is the intersection of the orange. So 4 times this would be 800 plus 4 times that is 400. That would make 1200. So 4, 4 looks good. Again, you could solve these systems if you had to, but a lot of times if you make a good graph, you'll see it. So then we have 5, 2. So 5, 2, again, checking it. Does it make the green one right? Green one, yes. 5 plus 2 is 7. Does it make the orange one correct? 5 would be 1,000 plus 200 is 1,200. So those are our coordinates. Now we have to remember, what was our function? We've got our coordinates. We've got our feasible region. Feasible region is the name what we have for that polygonal convex set again. And now we've got our function to maximize. So f of xy is 500x plus 300y. So again, f of xy is 500x plus 300y, and we've got to find f of our vertices. So, because our max or mins are always going to occur at those vertices. Those extreme values are always going to be there. So 2 times 500 is 1,000, plus 5 times 300 is 1,500. So I get $2,500 profit from those acres if I do 2, 5. If I do 4, 4, I get 4 times 500 is 2,000. Plus 4 times 300 is 1,200. So I get a little bit more there. I get 3,200 in profit with 4, 4. And f of 5, 2. F of 5, 2 would be 5 times 5 is 2,500. And 2 times 3 is 600. So that would be, it's supposed to be plus, sorry. what is that, 3,100. So it looks like this would be where our maximum occurs, which means we would do 4 acres, and you got to write out this solution, 4 acres of wheat and 4 acres of rye. And we are done with this problem. So again, just another example for you. I didn't want to put it in one long video, so you've got a couple videos you can watch. And that's it, guys. Go ahead and get the homework done. Hopefully that helped you with a little bit more knowledge. All right, so have a wonderful day.